Hello everyone, Sahili here from the Classcipe Operations team. Welcome to Classcipe Expert Exchange Forum first edition. Classcipe is a New Zealand-based company aiming to create a global community for educators and learners to share their knowledge and experiences. With us, you can create your unit plan and tasks more easily and customize your template with accurate content recommendations. Our platform function includes interactive slides, customized templates, online, offline, and hybrid learning functions, managing classroom, co-teach, instant feedback, and many more. Do follow us on our social media to receive more information and updates. Moving on to the issuance of certificates, the certificate of attendance will be issued to those attending the live session uninterrupted until the end. The feedback form will be sent to the chat box. You need to complete and submit it to get the certificate. We take 14 working days to issue certificates. Now let me welcome our esteemed workshop facilitator, Mr. Harirajan. Mr. Rajan has dedicated himself to the field of education since 2008. For over a decade, Mr. Rajan has been an integral part of an international school in Penang, Malaysia, where his expertise has illuminated the minds of countless young learners. His roles are as diverse as they are impressive, including being a teacher of IB MYP Science and IGCSE Chemistry, not to mention his profound contributions to the IBDP as both a chemistry teacher and an extended essay supervisor. He is also a chemistry IGCSE examiner and Edexcel IGCSE and A-level examiner. As we proceed to today's workshop, we are privileged to have Mr. Rajan share his insights with us. So without further ado, let's welcome Mr. Rajan. Welcome to the workshop, sir. And you can start sharing your screen and go ahead with the workshop. Thank you.
All right. Thank you, Sahili. And welcome everyone. It's glad to actually see different people from different areas of the world thanks to this whole online thing. So I'm just going to share my screen for now. Okay, so today we'll be talking about grading consistency in IGCSE chemistry, focusing on paper 6. And I think I don't need a little introduction about myself. I think Sahili actually mentioned all these already. So my main focus in school is definitely the last 4 years, which is the high school, focusing on chemistry, but I have taught IGCSE physics and biology and IBDP biology as well before. And within the school, I've also been doing supervisor for for extended essay for chemistry ever since I started in the school itself. And for leisure, I enjoy traveling to explore nature, focusing on hiking and trekking of hills, mountains, and volcanoes. So it's something outside my professional life as well. So the objective of today's session is to have a clear understanding of the grading criteria for paper 6, discuss strategies for ensuring fairness and equity in grading, including techniques for minimizing bias and subjective judgment, identify common challenges and ambiguities in grading, such as borderline cases or subjective assessments, and discuss strategies for addressing these issues effectively. Okay, so just a little introduction. Why I chose paper 6 is because it is the only paper in the IGCSE Cambridge component that is required for all students, including core and extended students. So if you notice that paper 1 and 3 is only done by core students, paper 2 and 4 only done by extended, and paper 6 becomes the one that is done for all core and extended. So meaning to say, the understanding is paper 6 and paper 5, if your school does it, is on the core syllabus. So that means the practicals or the investigations that they can ask in paper 6 has to come from the core, because these are the core bit is the one that both core and extended students actually do. And the weightings in terms of assessment, you've got assessment. So here paper 6 is going to focus on assessment objective 3, which is on experimental skills and investigations. Focusing on paper 6, it is a 1-hour paper, 40 marks, all items are compulsory. And as I mentioned, it tests assessment objectives AO3, and candidates will not be required to do experiments as part of this test. So ever since I've been teaching IGCSE, this is the paper that my school has always been doing due to the constraint of running a paper 5. Paper 5 is where students actually do the practical in at the same time. all right, but we don't have enough space, so we've always chosen paper 6. So here, notes for, I'll focus on the notes. So with the new syllabus, the notes for use in qualitative analysis are provided for both paper 5 and 6, which is actually what needed to be done at the start of GCSE. It is ridiculous asking students to memorize that whole list of testing of cations and anions and gas testing and flame test. All right, so to start off, because all the paper 6 have got the same style of questions that kind of reoccur in terms of, there's only 4 questions. The first question is always on a practical, or identifying apparatus or glassware of the practical a little bit. The second one is most probably going to be your graphing part. The third one is the testing of cations and anions. And the fourth one is the design experiment. So I think Sahili has actually put a link onto this. Can everyone please open up the question paper and the mark scheme?
Sathan has just shared a
Okay,
link in
sorry.
the chat box for all the participants. So we just request you to access that link so that you have all the access, all of you will get access to this slide deck and you can interact to your facilitator through the add-on functions. But just give us 1 minute. You may appear as a blocked. So Sathan will go and unblock you all. So it will just take a few seconds. So please access the link that is shared in the chat. It will ask you to log into the platform and you will be able to see all the slides that Mr. Hari is sharing on the screen. Simultaneously, you will have access to all the materials that he is sharing in the workshop. Thank you.
Thank you,
In
Sahili.
case you have any problem, just you can unmute and ask also. That is also fine.
Okay, when you're able to access the paper I'm talking about, maybe you can just put a thumbs up in your reaction so that I know it, so that I can proceed. I've got the paper open on my iPad on here as well. Okay, so just a little background. The reason I chose a March paper is because it is only done by one country in the world, which is India. And I think it's because of the whole academic session being different and the student population doing IGCSE in this country is large. They actually decided to open up a paper maybe not so long ago, maybe about 5 or 8 years ago. All right. And I always use the March paper to actually give practice questions for my students, is because somehow it is the most challenging when in comparison between the May, June, and the November, December of the same year. So I'm not too sure why it's the most challenging, but I'm not too sure. Maybe it's because of the population of them doing it. And a secondary focus of this session is, because it's a practical based paper, we're going to be looking at how we can incorporate some of these needed criteria explicitly within our lessons. Because I do understand that some of the practicals may not be able to be done in a school setting. So obviously we as educators, we are have a wealth of knowledge. So we usually use like simulations or videos to actually kind of complement what we can't actually do. But obviously the best is going to be so that the students actually do it as part of a class practical. Sahili, maybe just let me know when I can carry on.
Yeah, I think you can go to the next slide because I have already shared this link in the chat. So if they are not on the Classcipe slide deck, they can still access the document of the papers. Yeah.
Okay, all right. So the following slides from here on, I just wanted to remind that if you have any questions, you can actually unmute yourself and actually ask it verbally, or you have this option to answer or enter your text answer or question, not answer, question, with regards to the question that we actually be going through. So I've broken it up into the 4 different questions and only focused on questions that parts of questions that have or may have ambiguity that we need to really focus on. But if I didn't go through that part and you actually have queries regarding that, please put it into, type it out as a question or unmute yourself, and we'll hope to actually answer that question. So we look at question number 1. It is a practical based question in terms of where the first question asks to actually label the apparatus A. So my students actually had an issue with this question in a sense that we come from a background of English as second language. So if you notice that the mark scheme can be very strict in terms of apparatus and glassware. So the only answer accepted was water bath or /trough. So trough is not a word that in Malaysia we commonly use. So students tend to use the term tray. So when actually marking papers, these are things that usually I ask the principal examiner or the head examiner, and they say that a tray, in ideology, a tray is something flatter, so it cannot be the answer. So this is some things that later on I actually incorporate during my classroom itself, using the appropriate keywords based on the mark scheme. I didn't want to use water bath as an answer or something I put in my lessons, is because water baths give the impression that it is something that you can manipulate temperature for. So a lot of our students actually feel or have this understanding that water bath is something, could be an ice bath, could be a temperature based water bath. So I don't want to confuse them. So I started using the word trough a lot, right? So the marks, so in terms of this question, part 1A, the mark scheme can be very strict with terminologies or keywords. So make sure these are used regularly during lessons. So if you were to have an assessment, make sure you're strictly marking these kinds of keywords to put your students on the right pathway in terms of exactly naming it as how Cambridge wants it. We do understand it's an IGCSE, not GCSE, but some of these things, they have no bending on of rules regarding it, right? So question 1A is the main one I picked out. I think B and C is kind of understandable because it uses concepts, right? So I'm going to skip that and move on to question D. Okay, so I forgot to put question D here. So question D and E focuses on the concept of students actually needing to do the practical. So with paper 6, because it's based on the core, the idea is the practicals cannot come up from the supplement part of the of the guide, of the syllabus, because it is a paper done by all core and extended students. So all practicals has to come out from the core bit itself. Okay. So, but from time to time, we have seen that some of the things tend to do appear from the supplement bit. Especially I've noticed that in the supplement, one of the chapters, they were talking about displacement reactions or reactivity series of metals and halogens appear in the supplement, which is the extended paper, but doesn't appear in the core. So some of times you need to read within the syllabus itself, and where you can do it, please make sure you're doing it. So for question D, students will not understand why the aqueous bromine does not change the color when the first part or the first few tubes that contain the gas was actually tested. So if they've actually done that experiment and they've actually tested the first few tubes, then they would get the understanding that the whole setup is already filled with gas. So the first few tubes that you get is actually air, and it's not the pure cracking product from cracking. And question 1E deals with hazards. So explain what happens if the delivery tube is not removed from the water as soon as the heating is stopped. So I like doing this experiment where I choose one of a very, very, very old boiling tube where I know it will break or will crack at least. So I do it as a demonstration because, again, due to safety measures within the lab, so I do it as a demonstration where I actually deliberately make the mistake. And then I get students to think about, why did it crack? What should I do so that I avoid that that breaking of the tube to happen? So these are things I feel like is very, very applied, and students will never get the understanding from rote learning. So we all have this impression that IGCSE is very much rote learning, unlike the DP, because I teach the DP chemistry as well, which is very hands-on. But when it comes to paper 6, there is a certain degree of where students need it to be hands-on before they can actually understand how to apply it. So that's why I put as an asterisk there. Best if this investigation can be done as a demonstration in class. A video may be suitable as a substitute, but I've gone through all videos that are on YouTube, and a lot of the videos actually mention the hazard and remove the tube beforehand, but doesn't have, I couldn't find a video where it actually shows what if the tube was not removed within time and then the breaking happens. So it could be something that you plan within your lesson to actually have this as a demonstration to show that the breaking actually happens.
We
Thank you,
have
Omnia.
a reply in the chat from Dr. Omnia. Yeah,
Yeah.
she's acknowledging that it's really a great idea what you
All right.
just now.
Thank you, Omnia. So these are small little things that you may want to try out. So maybe try out first and have one really, really very old boiling tube, because a new one may not work. So you don't want to students to see it as not a hazard, because it is actually a hazard. Right. So I'm going to move on to question number 2, which is the big one. All right. So if you have the paper with you, my first one, I myself went through this paper, and the language in this question particularly was very, very confusing. So this is something that we want to implement explicitly within the classroom. So I put here, pay attention to the language used in the questions or instructions. So if you look at, they've only given instructions for experiment 1 and experiment 2. And then experiment 3 goes, repeat experiment 2. Experiment 4, repeat experiment 2. Experiment 5, repeat experiment 2. So the focus is a lot of students didn't understand it. Why were they asking to repeat experiment 2? So now go to experiment 2, read the first point. Use the burette to add 0.5 centimeter cube of distilled water to the mixture in the boiling tube from the previous experiment. So when it says so, basically it means that experiment 3 is repeating experiment 2 but adding 0.5 more. Experiment 4 is repeating experiment 2, but the 0.5 addition should be from experiment 3. And then experiment 5, the 0.5 increase should be from experiment 4. So again, a lot of my students also come from Korea, Japan, a lot of English second language. This was a very challenging question. Focus on the language, and understanding of the instructions is something very, very vital, I feel, especially if it's an English as second language region, because sometimes students don't read the question thoroughly. Even those with English first language may have kind of an issue understanding it, right? So this is something that will get better. So what I try to do is, a lot of my classroom practical is using paper 5. So paper 5 is actually a practical based paper that the students have to do it under exam conditions. So I usually use that paper to actually run practicals in my lessons for IGCSE, and I use the A levels paper 3, Cambridge paper 3, the same manner for my DP classes. So it is with instructions, it is based on the syllabus. It's just a different way of getting students to actually focus on the language of Cambridge IGCSE, right? So the next one, reading of the thermometer. So this one became an issue with decimal places that is required for the thermometer reading. So pay attention to the required decimal places needed. So uncertainties is not in the syllabus, but I include it in my IGCSE syllabus in terms of not the uncertainty calculation that's done in DP, but just understanding what uncertainty is and picking up uncertainty for especially analog apparatus. So I actually do this as a mini lesson, maybe an hour of my whole year. Do it in year 10, in the first year itself, where I get students to actually pick up uncertainties of different apparatus. The burette, the graduated pipette already has the uncertainty, but burette measuring cylinder thermometer is a big one. So the understanding is the analog apparatus, the uncertainty is half what the smallest reading is. So in this question, the smallest reading is 1 ml or 1 centimeter cube. So that means the student need to understand that the uncertainty of this thermometer is 0.5 plus minus 0.5 centimeter cube. So that means the only acceptable reading are those with answer with a 0.0 or a 0.5. So some of the readings here in this one may not be very, very apparent. But if you look at experiment 4's reading, a lot of students feel that it is slightly more than a 0.5. Could I go with a 0.8? That is not part of the mark scheme. So you cannot just put a value just because you feel it's not a 0.5 or not a 0.0 and it goes closer to the next one or closer to the previous one. Anything has to be a 0.5 or a 0.0 only. So this is very, very strict. Why? Because the mark scheme is very strict. So the mark scheme for this is, it mentions total volume of water, or sorry, temperature when solid starts to form. So it's 4 marks. all correct, only does the student get the mark. So sometimes I feel it's a bit unfair because students need to get all the 5 values correct before you can get that 1 out of 4 marks. And then the other marks are given in different places. So this is something that's why you need to make sure that your students are aware. Again, this is something that you may want to incorporate within your lessons itself. So I use this as an ATL. So in terms of ATLs of either communication, so my school is big on ATLs because it's the whole IB philosophy of focusing on the ATLs. So having students run this practical or run a practical and focusing on some ATLs that you can assess becomes a good activity, right? So moving on. So the next question is the graph. So for this question, the horizontal axis, the x-axis has already been given for the scale, and the y-axis is the one that students need to actually come up with their own scale. So my rule for graph is the graph should maximize the space because 1 mark is given for appropriate scale. So what is appropriate? So technically, some people may say, oh, your graph should cover 3/4, but then that's in a huge graph paper. I tell them, go as maximum as you can because you want your points to be clearly visible. So that's why the scale of axis needs to be appropriate. So this is where error carry forward. So I think as examiners, a lot of us, as even normal educators, a lot of us tend to haphazardly give the ECF. So technically, an ECF can only be given for the next question after the error has been made, not within the question. If it's within the question, that question has to be more than 1 mark. So for example, if you look through a stoichiometry question in paper 4, it's going to be a 4-mark question. The first answer is wrong, you mark it wrong. But if that answer is used correctly in the consecutive ways to find whatever they're required to find, that is ECF. So here, if the students have actually read the thermometer wrongly, you've actually marked them wrong in the first question. You cannot mark them wrong for the same mistake that appears throughout the paper. That is the rule. So it is positive marking. So if I have a student who didn't get that mark for the thermometer reading, but however, he or she has plotted that wrong points correctly onto the graph paper, he or she should get marks for the plotting. So that is ECF, that's error carry forward. So we are acknowledging that the student, yes, didn't make a mistake in one skill, but is actually correct in the other skill areas. So now for the plotting, it's just directly said 2 marks. If you have the mark scheme open with you, if I remember vaguely, it's mark 2 and mark 3 for plots. So if that's 5 points, when do I actually award 2 marks? When do I actually award 1 mark? It is the all or nothing rule. There is no half mark, there is no quarter mark, and you cannot deduct marks. So I only give 2 marks if full marks, if all the 5 plots are correct. If 4 are correct and 3 are correct, I give 1 mark. If 2 and 1 are correct, I give 0 mark. So I go for the half rule. So half downwards, you get 0. Anything between half to less than complete, you get the 1 mark. So this is the rule, and this is what positive marking is about, right? We don't deduct, but we just don't award, right? So the other thing is the graph. 1 final mark is given for the graph. And I think this is very, very important, especially for the physical sciences, physics and chemistry. There is no need for your graph to always be a straight line. You need to actually, again, explicitly do this in classrooms to take them away from the mindset that a best fit is a straight line. Now, I've noticed this, not to this bio, I've noticed this that a lot of students bring their understanding from biology. And if I'm not mistaken, a lot of graphs drawn for biology produces a linear graph. So using that in mind, students always feel that, oh, in biology, it should always be a linear, a line of best fit is a straight line. In chemistry and physics, it may deviate a little bit. The correct way of actually drawing the graph is the line of best fit that follows the points. So if you look at the mark scheme for this, it actually mentions that the graph should be a curve, and the curve is underlined. That means If when I mark this paper, I don't see a curve at all, that mark is not given at all. So again, these are points that we should be, as educators, we should be picking up and implementing it explicitly within our lessons, so that we are actually teaching them correctly for the exam, so that we know this is what is actually going to come out, right? So again, the graph is an ECF. If the points have been read wrongly, you mark them wrong. If it's plotted, the wrong points plotted correctly on the graph paper, correct. If the graph is appropriate to the points that they've plotted, you mark them correct. So that is ECF, right? So here I also mentioned line of best fit need to be a straight line. It should follow the trend of the plots, right? Now, the next part is C. So in C, they're asking you for extrapolation. It's a very common question, right? Very common question in terms of after the processing of the graph, or which is the processing of the graph, sorry. So they're asking you to extrapolate lines, blah, blah, blah. But here, surprisingly for this paper, it was 3 marks. Usually it's only 3 marks. Usually it's only 2 marks. Again, this question has got ECF based on the graph of the candidate. So if it's 3 marks, clearly 1 mark is for the dotted or full line drawn from x-axis to meet the graph. 1 mark for dotted or full line drawn from the graph where it needs to meet the y. And 1 mark is for the value. So if the student only has written the value and not done anything in terms of to show extrapolation on the graph, the candidate only gets the mark for the value, but not for the extrapolation. Again, something that we should be explicitly doing within our classrooms itself. Now, sometimes a question like this is 2 marks. So that means the extrapolation is only 1 mark. Now, be careful. Sometimes they could be very strict. That means dotted lines drawn from X to graph and from graph to Y is the 1 mark. It's not half-half, okay? So please make sure that we are doing this reoccurringly so that the students actually get this and pick this up as a skill. This is what I need to do. If I'm asked to extrapolate, I know I need to actually draw from the X to the graph, from the graph to the Y, okay? So, and then part D is okay, not too bad. Now, the other focus is within the questions that follow the graph after that, I wanted to pick up a few things. So here, there is a question where the answer was accuracy. For example, F part 1, state the advantage of using a burette rather than a measuring cylinder to measure the volume of water. Again, the whole concept of accuracy and precision and reliability, nowhere in the syllabus explicitly it mentions, but in the skills bit, it is kind of implicitly mentioned. So again, it is worthy to actually have this as one lesson, especially when you're doing the unit on experimental techniques. Teach them about what's the difference between accuracy and precision. How could you answer questions? What's the difference between reliability? So for example, a lot of times students actually, if a question comes out, how can I make this a fair test, all right? So when a question comes out, how do I make this investigation a fair test? Students always answer, just do repeats. That is an incomplete answer. Now, this is where it gets unfair. It's a 1 mark question. It's not in this paper, but I just thought about it. It's a 1 mark question where the answer should be doing repeats and taking the mean value. Both this needs to be as part of the answer to get that mere 1 mark. Again, something that you can implement explicitly in the classroom, right? And then the difference between accuracy and precision, very, very important. So here the answer is accuracy. Now, if you go to F part 2, the question in part 1 and part 2 seems or reads very, very similarly. So state the advantage of using now a burette rather than a volumetric pipette to measure the volume of water. Okay, so this is where teaching uncertainties in classrooms can actually be a come of a benefit, because most times the burette and the volumetric pipette have got the same uncertainty. So the use of this is not for accuracy or precision. the use of this is totally something else, right? So basically the use of a burette rather than a volumetric pipette is because you can actually remove any amounts bit by bit, whereas a graduated pipette or a volumetric pipette has got one reading for the whole thing. If it's a pipette of 25 centimeter cube, you cannot say, I want to use this and elute out 20 centimeter cube. When you elute out from the graduated pipette, it has to be the whole 25 centimeter cube. So this is where, again, building this as part of lessons becomes the main agenda, especially in a practical based one, all right? So the last bit of this question is 2G, where it's 2 marks. So explain the disadvantages of adding the 2 centimeter cube of water in 1 centimeter cube portions rather than 0.5 centimeter cube portions. So this is where my students actually didn't understand the question. So I actually told them that imagine now, if you can only elute out a maximum of 2 centimeter cube, would I do every 1 centimeter cube increments, or would I rather have more data to collect to actually do a 0.5? So if the maximum I can elute out is 2 centimeter cube, and the difference is only one, if I'm going to take out every 1 centimeter cube, I only have 2 sets of data. But if I take out 0.5 centimeter cube every time, I'm going to have at least 4 sets of data if my maximum is still 2. So get them to evaluate. What is the difference? What is the reliability now of actually taking 2 sets of data against, 4 sets of data, right? So get them to actually now think about, how does this affect my data processing? If I have 2 sets of data, how would my graph look like? If I have 4 sets of data, would it be a better graph? Would it be a worse graph? Again, get them to evaluate it. Right? Obviously, by that time, by that age, they should understand that more sets of data gives higher reliability compared to less amount sets of data, right? And if they still don't, this is something that you need to actually address now, or mention to the lower secondary school teachers that this needs to be implemented way before, because it's something a bit basic, right? All good, I assume. All right, moving on. Question 3. Again, it's a typical question. We always see one question is always on testing of cations, anions, gases, or flame tests. I'm very, very relieved that now they actually give the tables for testing of ions and gases, flame tests, and cations, anions, and gases, flame tests as at the end of the paper. So note that paper 6 doesn't have a periodic table at the end. So that means there's no need for stoichiometry and whatnot. So students can be a bit relieved. But the tables for these are actually given at the end of the paper. So there is no need to memorize. For paper 6, now, this is where the issue comes up. What Cambridge has done is, okay, given this set of tables as part of paper 6, but not given it as part of paper 2 and 4. So does that mean that questions like this don't come out in 2 and 4? No, they do come out in paper 2 and 4. But from the years that they've started giving this table at the end, I've picked up questions of testings of ions, gases, and flame tests. I've so far not found anything of testing of ions. But questions from flame tests and gases do come out in paper 4, especially gases. So I feel that it's a bit easier because testing of gases is something that we've done. In my school, we do it as the first year of secondary itself, year 7. Okay, so testing of hydrogen, oxygen, nitrogen, maybe, ammonia is not there yet, but oxygen, hydrogen is definitely done, and carbon dioxide. So I would actually expect that a lot of my students actually have that ingrained in their minds already. How do I actually test for carbon dioxide or oxygen or actually hydrogen? Okay, now the rule for testing of any of these cations and ions, flame tests, whatsoever, is it's always a 2-mark question. Okay, so if they're asking you so the 2-mark is, for example, what was the reagent used? 1 mark. What is the positive test for that? 1 mark. So for example, if you're testing, if you know it's hydrogen, how do I get 2 marks for the hydrogen? 1 mark is given to mention that it is actually a lighted splint. Second mark is lighted splint goes off with a squeaky pop. that's 2 marks. If it's testing for carbon dioxide, 1 mark to use lime water. Second mark, lime water goes cloudy or murky. Okay, so again, always implement this explicitly within your classrooms. It can be done for any sorts of the practical, right? The best one I feel for hydrogen is when you're doing acids and bases, reacting metals with acid, get them to test the hydrogen, you get it a pop sound. For oxygen, I do it with electrolysis of water. You get hydrogen, you get oxygen, test it out. Testing of chlorine also done within electrolysis. If I have like concentrated chloride for something, I test chlorine, it bleaches litmus paper or bleaches litmus paper. Ammonia is the one that is a bit tricky because it's a specific test that cannot usually be incorporated with a different investigation, right? So we can already see that this testing of gases can be done throughout the syllabus in other means other than only that one topic at the end. So try to do it. Try to build that understanding then itself, that maybe when it actually comes to that unit of testing of gases and ions, you don't have to do the ones that have already been implemented or explicitly done. You only do the ones that focuses on the anion and the cation, right? Okay, the last question, which is question 4, which is a design question always, right? So it is always a design question. Now, so I would like us or the participants to actually do this 5 minutes. So you've got the question with you, okay, on question 4. Can you just take 5 minutes to actually jot down in your own sheets of paper, or if you want to write it as a response, that's up to you, on how would you attempt this question, okay? So you've been given metals. They mentioned that the reaction is exothermic. You can react it with hydrochloric acid to form hydrogen gas. How are you going to attempt this question? All right, so I'm just going to stop sharing for a little while. So if you have any questions, you can ask me. I'll give you about 5 minutes. All right, would someone care to share your idea? You can unmute and maybe share an idea of how, if you were a student, you would attempt this question.
I would like to start, and I'm sorry
Yes,
for my voice. I'm really sick. I'm really sorry.
Thank
Okay,
you.
I would the part where reactions are exothermic, of course, they can do this through the temperature measurement and everything. But the thing is, I've taught my students to think about this in the way of the gas syringe, the rate of reaction through the gas syringe. I feel this is easier for them, and it's easier for them to interpret. So I would say through the gas syringe method, they would specify the volumes of everything used and the apparatus used, so 3 cubic centimeters. Do I say the specific steps I wrote?
No, that's fine. Okay, so thank you, Omnia. So as chemists, actually, we kind of know that is how we answer the question, right? So we know that because we've done the unit of acids and bases, so they react, and in the question they mentioned that hydrogen gas is revolved, and Omnia mentioned, yes, we can use the gas syringe method. And how do we actually, and also they've mentioned that it's exothermic. So there's 2 methods that we can actually use. So I'm going to share my screen again just to actually highlight the key points. So what I feel that is important with the design style question is students tend to take this as something very similar between all the 3 sciences. It is not. Okay, so sometimes if you look at a question like this, or some of the questions in chemistry, they may not be a very clear independent variable or very clear dependent variable. So it's you have to actually make sure the students understand that, right? So for this one is quite clear. So and students tend to look at biology again as the science, a lot of students do, and they tend to answer the chemistry one in terms of the bio one, which can be wrong in certain areas because I've taught biology before, and all the design questions in biology deals with rate. So because it deals with rate of photosynthesis, rate of respiration, rate of transpiration. So because it deals with rate, there is a certain kind of design that can be carried forward for all kind of design questions in bio. But in chemistry is different. One question I've seen before where they've asked, how can a student find out the percentage purity? To find out percentage purity, there isn't, for example, a very standardized dependent variable, or what is your independent variable? So how do I actually tell my students is, imagine if you are to do it, how would you actually list down step by step how you would run the practical. Forget about listing of variables. Maybe the only variable you can list is control variables, but other than that, everything else should be step by step. And whenever I see students put down in their last there the hazards or the ethical issues that may arise, this is a very bio thing. Bio requires hazards and ethics as part of the mark scheme. Chemistry, maybe to a certain extent, physics, physical sciences, that is not part of the mark scheme, right? So the first step I always get students is you have to list down somewhere in your whole step by step is the appropriate apparatus used. So I see the design question is where we as educators can actually give the maximum of positive marking, right? We want to actually acknowledge that the students have actually have that skill of applying it, right? So appropriate apparatus use is important. So for example, like Omnia mentioned the gas syringe. So if a student mentions syringe, that's wrong. It should be a gas syringe. Conical flask is a conical flask should be used, a conical flask with side arm or whatnot, right? So I always tell my students to actually maybe draw out the setup, draw out the setup so that it's easier for you to explain from your drawing, especially if it's an electrolysis practical design. Draw out the whole electrolysis, then you explain in terms of sentences, because sometimes labeling of apparatus on the drawing is accepted as answers, okay? So in terms of variables, control variables, okay, so here I put at least five control variables listed, because sometimes the mark scheme deviates. So I think this mark scheme requires like 3 or 4. Sometimes they require 3, sometimes they require 4. So always do a little extra. I always tell students, I want you every time to list 5 control variables. Okay, and if you're not listing it, again, as educators, as examiners, we need to find it within the answer. If the student didn't put an exact list, please go through their step by step and pick out that 5 variables, 5 control variables in there. If they mention, for example, same mass of all powdered metals used, 1 tick, that is a control variable. Same volume of acid used for all, 1 tick again. They don't need to mention what volume was used, as long as the acknowledgement is going to be a fair test is good enough. And then we come the complete step-by-step procedure. And number 5, the results from the investigation is what students always forget. They need to have at least one conclusion on how they've actually deduced. Because here, the question says, plan an investigation to find the order or reactivity of the 3 metals. So if I'm going to follow Omnia's method, I need to mention, for example, the one that produced the highest amount or the largest volume of gas within 5 minutes is the most reactive metal. Or inversely, the one that produced the least amount of gas within 5 minutes is the least reactive. They need to have that sentence there. That is the results from investigation. They don't need to set it up. They don't need to have come up with the actual series. They need to acknowledge how they would pick up and make their series. And then, for example, if I'm going to use the temperature or thermometer method, they need to mention the one that gives out the highest change in temperature is the most reactive. Vice versa, the one that gives out the least is the least reactive. Okay, so the design question is a tricky one. It's always 6 marks. It's never less, never more. But the criteria in chemistry differs from year to year, and it definitely differs from the type of experiment to another. Okay, so sometimes it is also an experiment in terms of empirical formula. They will give student, for example, a certain compound, a hydrated compound, CuSO4, XH2O, asking them to write down a step-by-step, how do I find the value of X? What is the number of moles of water to the 1 mole of copper 2 sulfate? So in an experiment like this, I don't see clearly an independent variable nor a dependent variable. It's actually finding out something new. It's not a rate reaction. It's not a rate design. So if the students are unable to actually, so I always tell my students, I don't want you listing your independent, I don't want you listing your dependent. Most times I can see that when you're actually writing your step by step. Okay, so it's not a rule that they need to have the IV and DV because it differs from one investigation to another. All right, so that is the end of the paper. So I've got one more of my students' work. All right, so based on some question similar to that, what if the students have not answered according to the mark scheme? So the two methods that we just discussed is one is measuring the volume of gas given off. The other one is the temperature difference. But here, the method that in the mark scheme is what? The student is reacting the metal with the acid. Okay, so I'm going to let you see what my student did. So if you have, there's a link there. Can you please open up this link? Okay, I am going to share, just a minute. Let me open up that paper as well. Okay, so if we just spend like maybe 2 minutes first, just going through how I have marked that student in terms of positive marking. The student did not answer it in terms of reacting the acid and metal, and that's it. Okay, so if you notice, my student here has actually answered it in terms of reacting the acid with the metal and then getting the salt, right? And with that salt, doing a displacement reaction. So is that method wrong? It's not wrong, because the student acknowledges that the metal reacts with the acid to produce a salt, and that salt can also be used with a few different metals to actually find out the reactivity series in terms of temperature difference. Okay, so I am going to share my screen again. You all already have my students' work. Okay, so it's a very similar question, not exactly from this year. So cobalt, manganese, nickel metals react with hydrochloric acid to form hydrogen gas. Plan an investigation to find the order of reactivity of these three metals, provided with the same thing. How will be a fair test? How will use your results? So the student starts off, prepare the aqueous metal solutions by reacting cobalt with dilute hydrochloric acid in one test tube, blah, 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 and then measure initial temperature of the cobalt chloride solution with thermometer, place sample of manganese in the cobalt chloride. So if you're a novice examiner, you would think this whole method is wrong, all right? Because the mark scheme says it's the metal reacting with the acid and finding out the temperature difference of that, or finding out the volume evolved a gas of that. But if you look through the mark scheme, these are still parts of answers. So if the student has measured the initial temperature, 1 mark, it doesn't matter where the temperature is. Observe temperature change, 1 mark. Given a conclusion, 1 mark. And then the list of variables, same concentration of acid, same volume of hydrochloric acid used, same mass of each metal. Again, so please make sure that you are going through the steps. Do not omit out thinking, oh, the student has started or done a very wrong experiment. The student is totally wrong. It doesn't work that way. So we are looking at positive marking. Okay, so that's the end of the session. So we are here back for Q&A. If you have any Q&A, not too sure if I've been going too fast, if you're able to follow. So any feedback, any questions anyone has?
You can unmute and ask. And also, I have shared the feedback form in chat box. So I request all the attendees to fill out the feedback form, because based on that, we will issue your certificate of attendance. So please take 2 minutes. First, you fill up and submit the feedback form, and then you can exit the meeting. And meanwhile, if you wish to ask Mr. Hari anything, any feedback, any suggestions, anything, that please unmute and you can talk to him. And thank you, Mr. Hari, for the wonderful session. I was paying so much attention. I wish my school chemistry teacher would have been this good. I would have done better. But it was really informative and very well explained. The instructions and the explanations were very to the point and very precise. Thank you for this wonderful session, Mr. Hari.
Thank you. If you have any questions, something that within paper 6 at the moment, if you would like me to clarify, or things that I grazed through that I felt that it was quite clear with the mark scheme, please do ask now.
Charles has said thank you for the insight.
Yeah.
Then Mr. Morley said thank you very much, and same from Omnia as well. It
Thank you
was
so
really
much.
informative. I agree. Yeah, it was very informative.
Other than that, I suppose you can tell or inform Classcipe as part of the feedback form if ever you want to see something else,
Yes.
something different. I think all that is in the feedback form. I'm still teaching DP chemistry, so I've taught DP chemistry since 2010. So if you have anything, so I see this as a sharing session. It's not an expert. I'm not an expert. Okay, so I am not an expert. I am not the expert, but it is a sharing session for good practices or best practice. So I feel that is the best as educators. There is no one good method. There is multiple good methods put together to make it. There is no good teacher. There is only efficient and effective teachers, right? So I feel that collaboratively we do better as teachers. So all this that I've actually presented to you is something that my team and I actually do in school collaboratively within the ID, within examiners. So it's things that we can pick out that is kind of reoccurring. So maybe that's something that we could plan in the future for some collaboration sessions, So that's something, please include in the feedback form.
I was just thinking about the examples which you were giving, no, about the burette and the pipette, how to check the efficiency and all that. So that's why I was thinking, in the pipette you only have the one marking. If I have a 5 ml pipette, I have only one marking, so I have to suck the whatever solution it is till that marking, and then I use the entire thing. So it was really I could really relate. Whereas in the burette you have the each and every
Yes.
demarcation is there, the marking is very accurate, so actually you can just release the whatever you have at the bottom to have drop by drop, and then you can control it, no? So I could
Yes.
really read what you were saying, so which is more accurate.
Yeah.
And
So
how
so
to
I think
explain to the students.
yeah, because there are schools, a lot of schools with the IGCSE, they tend to do, rote learning, where a lot of times the practicals are not done, and we see this as an issue when we get new students into the DP. And I've got a couple of students just coming in for DP and then saying that, oh, sir, I've not seen a burette before. I don't know what a burette is. So that is kind of blasphemous for a chemist, a chemist. Every chemistry student needs to know what a burette is,
Yes.
right? Because it's one of the main things we use. So please make sure. So be effective educators. Do practicals in class, because that's the whole essence of science. It's the hands-on.
Yes.
So I see someone has asked for my email. I am on social media, so if you want to add me, I've got Facebook, Insta, and LinkedIn. So if you look at the poster, that's my name, Harirajan Varadarajan. So if you can type that in, we can actually link up on social media. If you want actually to collaborate between our schools, I don't mind, right? So we could collaborate. That's up to you.